Some of you might be wondering why we left this tent open half, right? But that's to give you a clear view of what's happening with the drones. The drones will get airborne from where you saw on the station. They'll be going out. You'll see them here on the screen. They will be. What you see on the screen is what is detected from the radar. Okay, the screen has gone blank. What you see on the radar is what you will see on the screen here. And what you see outside on the visuals is what you will be able to correlate quickly. So we, though it's a little uncomfortable in terms of temperature, sir, we just thought to give a live experience, and we thought that you should see both of them together. The first of the demonstrations will be drone taking off and using a repulsor beam. We will be able to repulse the incoming threat. In that case, the expected behavior is the drone will come back and land from where it has taken off. So that's the expectation from demonstration 1. I will run you through the demonstration 2 in continuity, and I'll explain what will happen with that. Drone has got just airborne, sir. You'll see it quickly in your visuals. It is right on top of us. A little while it will come on the radar as well. Call going out. Yes. You can see that there is some detection on the screen. That is the symbol. The symbol is the location of the drone. Track here, AA103, is the drone which is going out right to the side. This is the radar detection. That is the visual. Beyond the visual, it will always be on our radar. The drone has been engaged. Transmission has been lost. The drone is expected to climb higher. Now you can see that it is climbing up. In a typical return to home behavior, the drone will forget about its trajectory, climb up and reach back to where it came from. Since we launched it here, you'll see it is coming back to home base based on the activity that you just saw. This is demonstration number 1. That means when an incoming threat comes, it's detected, tracked, engaged, and expected repulsing activity has taken place. Drone is right on top of us right now. You can see it, and we'll move towards the second part of the demonstration. The expectation for the second would be that we will launch the same target much further this time. It will go towards the gate where you all entered. From there it will turn around. We will be continuously tracking that on our radar. So it will go towards the further distance of 600 to 700 meters, and then we will launch our counter drone. So this drone is expected to go north all the way to the top, and from there the drone is going to come into an attack mode. This drone will be the target drone, and we will also send out our interceptor, the drone that you saw on the top. It will take off. It will go towards the target. It will be autonomously engaged from the command center, and so it will autonomously engage this drone from commands which are coming from the command center. There is nobody flying that counter drone. It's just taking off. After that, it is left to the control of the detected track. The moment you see a detected track, autonomously system guides it towards it. The counter drone is almost at position. The drone that is the threat is further ahead. It is going north on the screen here. This is the hostile drone. This is the friendly drone, sir. You can see the green. This is the counter drone which you see closer to us. This is the hostile drone which is going away, and then we will slowly see that there is a detection, there is an engagement that will happen. This continues towards the gate. It is moving at a particular rate. This is the target drone, the counter drone which is closer to us. You can see it, sir, at 600, 700 meters you can still see, but beyond that the radar has to see. So we're trying to keep it in visual range for this particular demonstration, but the system is capable of detecting up to 5 kilometers from where you are. The radar is capable of detecting, and the same kind of actions are possible. The control links for the counter drone support up to 5 kilometers. You can see that, sir. It's a beautiful follow. The target is maneuvering, the interceptor is following. It can't escape at this point of time. So it is being engaged in a successful tail chase engagement. If whenever we enable a payload on top of this drone, you can either jam it, you can see what it is doing, or you can even shoot it down. That is the sequence that we expected it to happen. All this engagement is happening autonomously, and we are very happy to show this live to you, both visually as well as on the radar. No, this is a system controlled interception. You saw that line of engagement. So what's happening is this drone which is in the air is using a ground-to-air communication called MAVLink. It's a different protocol. From the command center to the drone, it is a wireless protocol. From the controller to the drone is another protocol. We bridge these two. So what's happening is the nav stack on the drone is being substituted with a new position to navigate. Usually when you give a navigation, you give it a prefixed path. We are changing the path of this particular drone. We are assigning a new direction to go. The target is coming in, we are giving him a new direction as per the target's maneuver. As per the target's maneuver, and then you will be able to see that it is coming right on top of you. You see the drones are beautifully, the counter drone is beautifully following the target drone. And this is all happening without any human flying the drone. The counter drone is following the target and target is following a prefix plan. Ops control? Clear to land. So we come to a conclusion of two live demonstrations, both the repulsor and the counter drone, only built in INDRAJAAL.
Thank you, Commander Sai, for explaining this to us so eloquently. That the AI can enable to be along with enterprises. An alumnus of computer science from the Purdue University. He will use multiple patents to automate the status, communication preparation, and authentication combination of words, giving him the instrumental in the design and development of the world's first high-altitude research center at 17,664 feet in the DRDO. It is also mentioned in the Guinness Book of World Records.
Be able to see a lot of the if a drone is coming in from across the border at even 100 kilometers away, you will be able to see it in a command and control center at the center of even in Delhi if required, right? So that is what this technology does, this spider mesh.
No,
If you have any questions, please fire away.
Necessary unit in every INDRAJAAL system, or it depends on the terrain, or depends on the area of
I think communication is like a base infrastructure on which the system is built, right? And if you are protecting only the CM's house, probably not required, right? Because sensors are enough to, one sensor is enough to cover a 3 kilometer radius or a 4 kilometer radius, so you probably don't need it in a CM's house kind of scenario. But what we have to understand is counter drone systems is a police matter now when it comes to state. So we cannot have CM's house being protected by system A and US embassy being protected by system B, because they are both going to interact with each other and probably find one friendly here is a enemy there, right? So all of them have to integrate with the police command and control center.
Is it susceptible to jamming? Can it be jammed?
No, this uses encrypted low level frequency which typically the jammers will not be able to see. So you see those are jammers here. I'll explain a little bit about how the jammers work as well.
This encrypted thing, you are saying that it cannot be jammed by any adversary or somebody.
I wouldn't say it cannot be jammed. I would say that existing jammers don't have the capability to do
So it has some vulnerability?
Yeah. As all communication networks do. It depends on how well the enemy is, right? How well informed the enemy is. I'm sorry? I think it's. I'll send you the spec. I'm not 100% clear about it.
Only the ISM band or the complete?
ISM band.
ISM band.
Yeah. ISM band, but I will give you a spec for it. I wouldn't be the right person to answer the technical specification questions. I'll get you a sheet which will explain all that. Yeah. Not the right guy. I'm sorry.
How does it differentiate between the threat and the threat rate?
So that comes when you get to the command and control center. This is just the communication infrastructure network, right? So I think when we look at the technologies there, the command and control center, which you see, basically integrates with IACCS, which is the Air Force Defense System, and Digital Sky, which is the civilian air system, right? So it basically, when it detects something, it's immediately going to check with both the systems, saying that is this a valid drone or it's a valid flight path, it's a registered flight path or not. Right, so that's the system that you'll see when we get there. So we can move on to the next one. It's for the sake of time. So this particular drone is called Skycop, right? It's basically focusing on following a threat, and we can load a camera on it, we can load a net on it, we can load various even small jammers on it, small radars on it. So this is the one that will, when we see a threat that is maybe 3 kilometers out, this is the one that's going to fly and follow it, right? So we're able to get visual line of sight of what this is, right? So this will be part of the demo when we see it today, saying that how the follow works and how we see the command and control center. But the idea of an interceptor drone is based on how today fighter aircrafts work. So if there is a threat that is coming in from a MiG aircraft from a border area, they immediately send out a sortie, they send out a plane to go follow it first to really understand the threat level. So this comes under the same principle, right? So drones are, unmanned drones are also going to follow the same principles of current airspace security, right? Which is saying that send out a drone and be able to track them first. So that's what this particular drone does. It has various applications, and this is when you look at these two drones, we have to understand that the underlying technology is what is important, because we are going to have the same drone in all sizes. So if you see a male drone coming, which is medium altitude, long endurance, right? That's a male drone. So the drone that is going to follow it will also be equivalently big, right? Because you will have to match the speed and the agility of the drone that is coming. So both of the Zombie and Skycop drones are going to have the entire range of spectrum, saying from micro, mini, large to. So typically when you design this system, if you are taking a location that we are designing it for, the two things that help us design is, one is what is the threat we are fighting against. For example, Saudi will fight against Iranian drones because the border is so close to their refineries. Now if you are taking something in the center of India, we know that nothing is going to be able to come that far, because flight time is not there, unless it's a male or a hill. Flight time will not reach the center of India. You need 3 hours of flight time, which is most probably not possible with the current drones that they have, and they'll probably be detected way before the Air Force and shot down, right? So now if you're in a border area, the threats are very different, right? So you have to decide what the threats are, and you have to decide the environment. Are we in the mountains? Are we beside a lake? Are we in a city surrounded by buildings? So these two factors help us design the system. So the answer to you is that how many countermeasures are we going to put? If a place has threat of swarm attack, we'll probably put a cassette of 50 counter drones that will launch, right? So there's the cassette launcher for a drone, but typically they will launch 50 drones very quickly. So you're talking about launching 50 drones in 32 seconds to 1 minute, right? So it has to launch very fast. So that's how we.
So this is your flagship one, right? So far.
This is our capability standpoint, right?
Okay.
But a lot of our zombie.
I mean,
drones,
in your inventory so far, I mean, this is the flagship one which you trying to project, right? And talk about your capability. So this particular drone and range, right?
Sure. I mean, we always try to find the flagship, but I always say there's no such thing as a flagship. It's a platform that the platform is the flagship, right? The drone, I'm telling you, drone is like an Android phone. Let us put it that way, right? There is no flagship. Today's Android phone is not relevant in 1 week, because there's a newer camera, newer this, newer.
Yeah, the size and
yes.
weight will be different, right?
It has a software inside.
Yes, the software is the key.
Which software? It is an indigenous made software. Does it require upgrading the software?
Every week.
Every week. Do you require internet connectivity for that? Outside source internet connectivity?
Spider mesh connectivity.
Is it susceptible to hacking?
Everything is, but I would say 99.99%.
No.
Yeah.
But there is a possibility that it could be hacked as well.
Yeah. Absolutely. Anything can be hacked. I mean, if we ever think that it cannot be hacked, then we are in the wrong business.
So what is the range here? I mean, this particular
This one is? I'm sorry.
range, detection range.
So this can not detection, flying range is about 5 kilometers.
That's fine. Okay.
So from the ground station, which is this in this location, it can go up to 5 kilometers and come back.
Okay.
Right? So because battery level is about 25 minutes, which is typical battery level.
I was asking this question from the standpoint of we have a long border, 4,500 kilometers of a border. If this is to be used in the border areas, how much susceptible is it for jamming, hacking and such like things, and whether it will get the permissions from the army headquarters for being put if it is susceptible to hacking. That was the
I would say that
premise before
distance
asking.
is not a measure of ability to hack. You will have to connect physically for hacking, but like again I said, there are various levels of if you use a quantum computer right now, yes, you can hack it, but does everybody have a quantum computer? No, right? So that's it's a tricky space.
This one-on-one doctrine of kamikaze operation, is it really worth it? I mean, can you not scale up the combat capabilities of the platform and
Nothing. There's nothing. Actually, I would say the jammer is a very interesting thing, right? I'll ask you this simple question. Today, when you see the demo, we'll actually jam this drone. Now, what the programming in this drone clearly says that when you jam it, it is go back to home, right? So when you jam it, that means it's jamming the RF signals of the drone. So drone is not receiving anything from the ground station. So that means it's programmed to go back home. Now it's very easy to program a drone saying that the home location is the target. So even if you jam it, it'll just go up and go to the target, right? So jamming itself, I would say, is a failure of a solution, because the second I jam something, it might jam it for 20 seconds, but then it's still moving towards the target. So how is it really going to stop it, right? So yes, as a current countermeasure maybe, but as we go forward, the only real cost-effective countermeasure are counter drones, because it has to be as intelligent as the drone coming. So you will have to match the intelligence level, and cost-wise also today, if you look at, I think they are using Patriot missiles in Saudi. That's 1 million. Even if the smallest drone, 1 million is spent every time it comes into a hail drone, 1 million, right? So you launch a Patriot missile, it's $1 million, right? So we are talking about what, $10,000, right? So it's like it's a no-brainer when it comes to counter drones.
So the only way to counter a swarm is a swarm, like our own
Absolutely, because to counter a swarm, you cannot have a human saying that, okay, click this, deploy this, click this, deploy that. There are 50, 100 coming at the same time, right?
And
So
lasers don't counter these.
So laser assumes one simple fact that you have to point at a single location for 10 seconds to laze. On a moving target, that's almost next to impossible, right? But if it's a big enough plane like a Global Hawk or something, yes, it makes sense. But anything below that, laser, and it's 20 crores a laser, right? So it's going to and a single kill, right? 20 crores for 30 seconds, it will kill one drone. So the math just doesn't add up, right? So the only and that's what our core proposition is, that the only way to counter these as a hard kill is counter drones, right? The jamming will only pause it or stall it for a little longer while we wait, but it's not really going to.
What is the electromagnetic
countermeasure it.
pulse?
EMP will kill you and them.
Acha, everybody.
Yeah, if you launch an EMP, they basically all your electronics and their electronics, everything fries. Spot jammer, that means it will jam in every direction, and this is a directional jammer, right? So we took one channel out of this and put it into that. So if you look at this focuses on 2400 to 2500 megahertz, right? Now the reality of the fact is that this is covering 7 frequencies, but the reality of that, any guy who is coming in to attack, first will look at the army RFP and be like, okay, they have released a requirement for jammer for these 7 frequencies. So let us tune our drone to another frequency that is not in these 7.
Right.
If I was on that side, that's what I would do, right? I'll be like, wait a second, I know what the RFP is, I know what the military has, and I know what their capability is, and that's what we do with all our neighboring countries also. We understand what is their current capability of defense, right? And that's how we plan attacks, right? It's not so. While, like I said, internal hinterland, like people just flying phantom drones and these, yes, it can jam them, but any serious threat, I would say jammer has limited capability. I would say 70%.
What is the range of both of these?
This one is a 2 kilometers, so when it's the point defense can do up to 1 kilometer when it's point defense, but if you do the directional jamming, it can do up to 2 kilometers. So today when we are flying the target, this is the one that's going to
They
jam
have a
it.
blind spot also, directional ones.
Uh,
What is the distance of blind?
Oh,
I mean, till what distance there's nothing will happen.
20-30 meters for this one, because only 1 kilometer, right? So that is a 5 kilometer jammer, the last one. Right? So that will have a little more blind spot, but this is like 50 meters max, right? After that it will jam.
This cater
All
for
these
GPS?
systems
No,
you have
it's
shown
RF
are
jamming.
RF.
proprietary green robotics systems.
No, green robotics. INDRAJAAL is a solution, right? Each like this, we have at least 4 different hardware manufacturers who supply to us, but the software is built by us on that, right?
Oh,
so it's the ability to
Software is yours.
yeah. So the way it integrates with our system is what makes it unique, right? Because to be able to control this system from the command and control system is where the core software capability lies.
No, because you have mentioned TN next to all the.
That's I mean the name, right?
Okay.
So where is manufacturing?
Huh?
Where is it built?
And this, I'm telling you, next month you come back here, there will be an upgraded jammer. I guarantee it. Right? This is. I'm telling you, this is the upgraded.
So where
one.
is it built? Where is manufactured?
This is manufactured in India.
Okay.
There's an Indian manufacturer who manufactures these.
Is one integrator or somebody?
There's a manufacturer. See, you have to understand that there are manufacturers, OEMs, who manufacture hardware, and there is a layer of core firmware, software, application, and solution services.
But at least at the top level, it happens at one place, right? I mean, somebody will have this device and then we'll have all the inputs together. So is it done at one place or I mean, you can't go multiple places to have different,
We do. That's the thing about INDRAJAAL. We are saying we are weapon and sensor agnostic.
Okay.
You want to deploy this in CM's house, we're not going to use this. They don't have permission to use this, right? This is only for defense, right? You cannot jam. If you open this jammer in a CM's house, it will block any aircraft that is, even a chopper that is flying, it will block it, right? So there is a lot of friendly jamming that will happen of using this in a civilian space. So it's purely for military, mil grade